Hi folks. So we had a small glitch in our live session today, which is a problem solving session in compiler design. We have successfully explained about the compiler design subject and a few announcements, and we were also able to solve two problems in the live session itself. I'll provide a link to the live session that we had to discontinue because of a technical glitch in the comment section below and also in the description section. So what we'll do now is we'll go from the third problem to the 10th problem in this video. So I'll explain each of these problems. I'll show the problem. I'll request you to pause it, and then we'll go into the solution itself, right? So let's solve the rest of the problems so that whatever we could not do because of a technical glitch, we will cover it in this session, right? So let's go to the third problem now. Again, at this point of time, okay, so this is the third problem. I hope it is clear to all of you. Again, please pause this video. Okay, please pause this video. Take a few minutes. It's okay at this point of time. This is basically early June. It's very important to get the solutions correct rather than speed. You'll anyway build up speed over a period of time. So please take some time, try to answer this question, pause this video here, see the solution, go through the, try to solve the problem, and then look at the solution that I'll present in just a few seconds. Okay. So here we go into the solution. Okay. So let's take this problem. So what is the question saying? The question is simply saying simplified grammar for this CFG is. So there are basically three simple steps if you have to simplify a grammar. First, you have to eliminate null productions. That's the first step. Again, in lot of compiler design, it is all about applying a bunch of simple steps. If you know the steps, if you know the concepts, compiler design is very easy to score, right? So let's eliminate null productions. Okay. So you have this null production here. That's the only null production. So what we'll do now is we will modify this as AA or ABB, right? Similarly, if this epsilon is placed here, this will become A itself because A epsilon is A itself. Similarly, we'll have, okay, so let me just do this. We'll have A generates AAA, or if you place this epsilon at A, you will get AA, right? Similarly, if you look at B, B generates BB or BBC. Again, C here is a variable, not a terminal. Similarly, C generates capital B. Cool. So the first step is done. The second step always is to remove or to eliminate unit productions. What are unit productions? Unit productions are X generates Y. Those are unit productions. Again, what are epsilon productions or null productions? X generates epsilon. Okay, so if you eliminate these, if you eliminate these unit productions, look at this. We have one unit production here, so we'll try to eliminate it. Rest everything stays the same. Look at this. These three steps stay the same. Only this will change. So this will stay the same. So this will be S generates AA or ABB or A. A doesn't change. AAA or AA. As far as B is concerned, B also does not have unit productions, so it remains the same. This is the unit production. So C generates everything that B generates. So this will be BB or BBC. Okay. Next, the third important step in this whole process is simply the elimination of useless symbols. The elimination of useless symbols. There's simply three core steps here. Okay. So if you notice, your symbol or variable B and C do not generate strings of only terminals, because you have a variable here, you have a variable here. Either directly or indirectly, if you think about it, either directly or indirectly, they can never generate strings which only contain terminal symbols. So because here is a variable, here is a variable. These are the only two productions that contain B and C. And B and C do not generate S or A. Remember, S can generate a terminal, S can generate strings which contain only terminal symbols. A also can generate strings which contain only terminal symbols, while B and C cannot. Right? That's the whole logic behind useless symbols, right? So you can completely discard these two symbols. While you're discarding these symbols, you can also ignore this symbol B here. Now this is S derives AA or A, because this is simply A. So let's ignore this, right? A generates AA or AA. So that's all. These are the only production rules that you will have. If you notice, this is same as option D. Look at this. This is same as option D after you remove useless symbols. Again, please understand that in these problem solving sessions, we expect that you know some of these core concepts. We expect that you already know it. We are only focusing on problem solving sessions here, right? We are giving a problem, explaining the solution in detail. We will not be able to explain all the concepts of useless symbols, unit productions and epsilon productions in depth here. We have covered that in a lot of detail in our course videos, and hence we have to skip here in the interest of time. Okay, so this is fairly simple, right? So this is the solution, that's all. So now let's go to the next problem. Okay, again, please pause this video, spend some time solving this problem. Okay, this might look crazy big, but it's actually a simple problem. So I'm assuming that you have paused it and solved the problem. Here is the solution. If you have not solved it, please pause it again. And again, you should always attempt it first before you see the solution. That's very, very important. Okay, look at this. Here you have left recursion. The question is saying the non-left recursive grammar for the following grammar is. Again, here is a left recursion, here is a left recursion. Similarly, here you have left recursions. So we want to get rid of left recursions, right? That's the whole idea. So for these production rules, let's first write it. Again, you just have to follow a very simple series of steps. Okay, so these two productions, or S generates SAB or S generates S exclamation, have left recursion. So let's just ignore it for a while. Look at all those which do not have that problem of left recursion. Okay, so let's look at this. So this is T. Again, we have explained this in our course videos. This generates S dash or BTB S dash, right? It's that simple. Now S dash itself, look at this. S dash itself will generate AB S dash or AB S dash or exclamation, because you ignore the S here, so you put the exclamation symbol and then place S dash here, or it can also generate epsilon, right? Again, we are just following the standard rules on how to remove left recursion that we have discussed in the course videos. It is by introducing a new variable called S dash and following these two steps. Again, if you are not clear of these steps, you should certainly learn these concepts, because if you know the concepts, it's straightforward here. In the interest of time, I will not be able to go into each of the concepts in depth. Again, we have solved tons of practice problems, tons of solved problems in our course videos. Okay, now let's look at this. So this is T generates T dash, because there is only epsilon here, right? All these three terms have the left recursion. So now we'll say T dash generates A T dash. I have A T dash or B T dash or C T dash or epsilon. Okay, so these two productions and these two productions are what I have, right? Now let's see which of these options is correct here. So if you notice carefully, okay, so let me see here. So this says T S dash B T B S dash. So this is matching with this. S dash generates this. So this is matching, this is matching. T generates T dash. T dash generates A T dash, B T dash, C T dash, epsilon. Yes. These four production rules, are there actually multiple production rules, because this is 1, this is 2, 3, 4, 5, 6, 7, 8, 9, 10. These 10 production rules are exactly what we want. If you notice, there is no left recursion here. There is right recursion, obviously. There is right recursion here. Okay, so there is also right recursion here. But all we want is a non-left recursive grammar. This is the equivalent non-left recursive grammar. That's all. You just have to apply this process wherein you introduce a new variable called S dash and T dash and follow the simple rules. Please remember, compiler design is simple if you know each of the steps carefully. Okay, so let's go to the next question now. Okay, again, please pause this video, try to solve it. I'll explain the solution also in detail. Okay, so I'm assuming that you have spent some time solving it. So these are your non-terminals, these are your terminals, right? This is your starting symbol, the standard stuff, that standard definition of a context-free grammar, right? We know this, right, very easily. Now you have a bunch of production rules. Again, these are your production rules, okay, numbered 1 to 7 to be clear. Now the question here says, what is the follow of F? We have learnt about first and follow of F. We have solved a lot of practice problems. This is a very common type of question that either is asked directly or indirectly in gate, right? So let's solve it. What is follow of F? Look at this. What is there after F here? If you notice this production rule, there is star here. Okay, there is surely star here. Now what else is there after F? Okay, so there is star, obviously, union. What else is there? If you notice, whatever follows T will also follow F because of this production rule. Look at this. Whatever follows T will also follow F. So you can write this as star union follow of T. Because of the okay, you can use this production rule or you can also use this production rule. Whatever follows T will follow F also. Either this production rule or this production rule, doesn't matter. From both of them, you'll get the same result. Now, if you recall, what is follow of T now? Look at this. Okay, let me just erase this here. Okay. So if you're careful enough, again, you have to be very careful here. What is follow of T? Look at this. Follow of T. What follows T? What follows T? Because of this production rule, you can say what follows T is nothing but the first of F. Okay, so it is first of F. You have to be careful with each of these rules. Union. Is there something else? What is follow of T? Look at this. Whatever follows T, because of this production rule, whatever follows E also follows T because of this production rule. So this is nothing but follow of E. What is first of F now? Look at this. What is first of F? F generates A, F generates B. So first of F will contain A comma B. Simple. What is follow of E now? Look at this. What is follow of E? What is E followed by? Look at this. If you notice, E is followed by plus here. Look at this. E is followed by, if you notice carefully, okay, let me erase these. E is followed by plus. So follow of E will contain plus. And remember that E is your starting symbol. As defined by the grammar, E is your starting symbol S. We often use S here, but here it's clearly mentioned that E is the starting symbol. Which means the follow of E will also be $. Right? So what is the follow of F? Follow of F will contain star, it will contain AB, it will contain plus, it will contain $. So which of these options has all of them? Star, AB plus $. Yes, option D is the right option. Again, it's all about following the rules carefully while keeping an eye on these production rules. If you make, again, this problem is simple, but it is very, very prone to silly mistakes. Lot of people make silly mistakes in compiler design. It's easy to score marks here. Okay, I'm repeating it multiple times so that you appreciate that you can literally get 3 to 5 marks here free of cost. Okay, okay, cool. So let's go to the next question. Okay, let me just scroll it. Okay, this is a lengthy question to read, but please read it. It is easy problem, but you have to read it carefully. Okay, please pause this video and try to solve it first. Okay, I'm assuming that you have spent some time trying to solve the problem. All that it's asking here, again, it tells you what are terminals here, right? It tells you all that. It gives you all that information. It says, what is the first of param list? Look at this. Where is your param list now? Okay, so where is your param list here? What is the first of param list? Okay, so param list generates param list comma param, right? And param list also generates param. Look at this. Param list generates param. So first of param list is nothing but first of param. Okay, look at this. First of param list is nothing but first of param. And first of param is also, is there any production rule with param list? Nothing. This is left recursive because you have param list here, param list here. Param list generates param. So first of param list is first of param. Okay. What is first of param now? Look at this. What is first of param? You have type here. Okay. This is nothing but it is a first of type. Again, there is only one production which has param on the left side. Okay. So you have first of type here. Now what is first of type? Where is your type here? Okay. Look at this. Type has t int, t double, t char. Look at this. It has t int, t double, t char and epsilon, all 4 actually. Okay. So it will generate, so first of type has t int, t double, t char and also epsilon. Epsilon basically means empty string anyway. So because there is empty string here, this is important. Okay, look at this. Because param generates type t indent and type itself can be epsilon. Because type can be epsilon, this could be epsilon. If this is epsilon, the first of param is also first of t indent. Look at this, because this is that's the catch here. That's the tricky catch here. Because type can be epsilon, this type I can replace it with epsilon, which means param can generate t. The first of param will have t ident, not indent, t ident. So you have to add t ident also as one of, again, these are all the terminals, t ident, t int, t double, t char, open braces, closed braces, semicolon and comma. These are all the terminals that you have. Of all these terminals, these 4 terminals are in the first of param list. Now, which of these options are correct now? This, right? So, many people will write answer as A. Look at this. If you stop here, if you just stopped here, if you did not realize that type generates epsilon and epsilon can be placed here, which means first of param is also t indent. If you did not realize that, you would go with A as an answer. That's why it's a tricky option where many people will make a mistake. But the right option here is B. Just have to be careful slightly. Again, this type of grammar is something that you may not see when you study grammars from a textbook or from any course. So this is given just to confuse you slightly. Okay, because whenever we see capital letters, we assume that it is actually it's actually variables or non-terminals. But here it clearly says that the terminals are represented using this. Right? Cool. So you have to be careful here. That's all. That's all is the trick. So here is the next question. This might look like a lengthy question, and it actually is a lengthy question. So it's okay to take 3 to 4 minutes to solve this problem because we are still in early June, and with practice you can solve it in much shorter period of time. Right? Please read the question very carefully and try to solve it. I hope I've scrolled it through. Yeah, there is nothing below this, right? So please take some time, think through it, carefully solve it step by step, because the steps are important here. If you know the steps, you can solve most of compiler design, and if you don't do silly mistakes. Again, I've drawn this solution on my notebook and I've put it here. So let's go again. These are the 4 production rules that we have. Remember that these are the 4 production rules that we have here. Okay. Let me use a slightly different color. Okay. So these are the 4 production rules. I've just written them here. So let's actually start building these terms, these states. That's how you do it, right? How do you do this whole thing, right? You just build your LR1 items, right? Or these states I0, I1, etc. We have shown lots of examples in the course videos. In case you're not sure about how to do it, please watch the videos and this will become like cakewalk. Okay. So let's look at this, right? So the very first, again, this is my starting symbol. So we'll just add it. Sorry, there is okay. So this is the first symbol. So we'll introduce a new symbol called S dash, and we'll say S dash generates dot S comma. The look ahead symbol is dollar here. Again, if you have forgotten this terminology, this is called a look ahead symbol. Again, if you have studied compiler design, this is straightforward stuff, right? So I'll explain this step by step. So this is a special production that we are adding with a look ahead symbol as dollar. Okay. Now this dot is just before S. Okay. So let's introduce all the productions which have S now. Okay. So we say S generates. We place the dot at the very beginning. Look at this. We place the dot at the very beginning. Because of this production rule, we'll get this. And the dollar stays the same. And because of the production rule 2, we will get this. Standard stuff. This is your I0. Okay. Now what is the question asking? Look at this. The question says very clearly, the closure of CLR item, this item in state I0 is. Look at this. It's talking about this state. Okay. So it's talking about this production rule, or this production rule with this look ahead symbol. Now if you notice, if you want this exact production rule, with this look ahead symbol, what do you need here? Again, you don't have to build the whole graph here with all the states. So all you need to do is you need to push this dot one step ahead. That's all you need, which means the transition in this graph from state I0, we only care about this parenthesis. So on the parenthesis, let's see what happens. That's the only thing we care about, right? So the moment again, because the question asks for that explicitly. The question doesn't ask us to build the whole graph with all the LR1 item states, right? It just says the closure of CLR1 item, this item in state I0 is. It clearly asks this. Okay. So this is what we have in I0. And now if the transition, the transition for this graph on dot is, you move, sorry, on open parenthesis is, you move the dot that side. So the first thing that you'll get here is S generates, open parenthesis, the dot is moved one step ahead, right? And dollar. Cool. Now, if you notice, the dot is there before L. So look at all the production rules that have L now. Look at all the production rules that have L. I think there is a small error that I have made here. Okay, so this is not S generates, this is L generates. Okay, my bad. Okay, this is L generates, not S generates. Okay, that's important. Okay, so let me just correct that for you. So this is L generates, not S generates. Okay, so because this dot is before L, look at all the production rules that have L. Let's add that. Okay, so when you add this, what do you do? L generates, you place the dot at the very beginning, standard process. And what you place here is what follows L. Because the dot is there before L, what follows L? Look at this. What follows L from these production rules? It's very simple to see. What follows L? L is followed by closed parenthesis, right? So corresponding to these two rules, look at this, corresponding to these two rules, you place them with the follow of L, which is closed parenthesis. So this is clear, this is clear, this is clear. Now if you notice, there is a dot again before L and there is a dot before S. So because of this production rule and this placement of dot, we'll again generate two more production rules here. Look at this, because of this. So L generates dot L comma S, comma, again, we have given this specific example because there is a very important reason why we picked this example. In this grammar, so again, in this grammar, the comma is also a terminal symbol. And we also use the comma to separate the production rule from the look ahead symbols. Okay, see, look at this. There is one comma. That's a standard nomenclature that we use, or the standard process that we use. We separate the production rule with the dot there and the look ahead symbols with a comma. But there is also a comma here, which is a terminal. That's what will create confusion. That's why we intentionally picked this example, because it could be confusing. Okay, so let's go here. So now, because of this production rule, remember, because of this production rule, we are generating these two. Again, this part is straightforward, this part is straightforward. Now let's look at the comma here. Okay, what is the follow of L here? What is the follow of L here? The follow of L here is comma. So this comma is the separator. I'll just put semicolon here. So this is your production rule. This is the look ahead symbol. Production rule, look ahead symbol. Easy to get confused. Okay. Next, because of this production rule, look at this. Now look at this, right? If you notice this carefully, there is a dot before S. So this will generate these two green ones. Again, I've chosen different colors here so that you can see the arrows. So what are all the production rules with S? You write the production rules with S. And the only tricky part now is, what is the follow? The follow part has to be thought through very carefully. Okay. The follow part now is nothing but closed parenthesis. Right? Look at this. The follow part is the tricky part that you have to be careful with. That's all. Okay. The follow part now is nothing but parenthesis. Okay. Similarly, so if you look at this, again, if you look at this, okay, so this has this production rule and this is the look ahead symbol. So this will again generate two more production rules because there is dot before S. This part is straightforward. Okay, so this part is straightforward. This part is also straightforward. Now, if you notice, if you notice this, the look ahead symbol is comma here, right? So the follow of S here, will be comma and comma. So these are all the production rules you get. Again, the trickiest part here is we use comma to separate the production rule and the look ahead symbols, but the production rule itself has comma as a terminal. So you have to be very careful when you write it. Even when I was writing this solution, I was being extremely careful because it's very easy to make mistakes. Okay, now if you notice all of them and if you simplify this grammar, look at this, it's very simple. So S generates this, okay, so you write it as is. Now let's look at L. L generates this, so it is here, look at this, it is here. Where else it is there? It is also here. So you place this, L generates dot L comma S, and on the look ahead symbol, it could either be comma or it could be closed parenthesis. That's why this is the look ahead symbol here. Similarly, you can combine this along with this, because the production part is the same. This production part and this production part are the same. Only the look aheads are different. So what are we saying here? Look ahead could be this or this, right? Very simple here. Similarly, look at S generates. So you have this production rule here. You have this production rule here. The look ahead symbols are changing, right? So you say the look ahead symbol can be closed parenthesis or comma. Similarly, you combine this and this, you'll get this. So this is the total solution. Now, which of the four is this solution? Let's look at this. So now of all the options, let's look at which of the options is the correct option now, right? So if you notice if you look at the look ahead symbols here, you have both close parenthesis and comma. So let's look at it here. So this has only dollar, this has dollar, this doesn't have two options, this has the two options. So C has to be the right option here, right? It's a straightforward question now, because this is the only LR item that we have here, or LR1 item, because we have one look ahead symbol here. It's the only LR1 item that we have here, which has two possibilities. Straightforward question. Again, with practice, you can do this much faster. Again, I've tried to explain the solution step by step carefully so that you understand the solution. And you also understand the reason why we gave this problem, because this comma can create a ton of confusion if you're not careful, right? I hope you understand that reason. Okay, so let's go to the next question now, right? So this is the 8th question, and this is also a lengthy question. I mean, especially if you're a beginner, this can feel slightly lengthy. So please take 3 to 4 minutes and try to solve this problem. Again, you have to follow all the steps to detect conflicts. Again, we have discussed in our course videos how to detect SR conflict, RR conflict, all of that stuff, right? Using the parse table and concepts like that, right? So please follow those steps carefully. Again, since this could be the first iteration of your practice, it's okay to take time as you progress through the course, as you progress through your practice before the exam. You can actually solve this in 2 minutes in the examination, 2 to 3 minutes in the examination, right? You can take 3 to 5 minutes now. It's okay. Getting it correct is important, because that will improve conceptual clarity than speed right now. You will improve on speed slowly. Speed has never been the problem for most GATE students. It's always concepts that's the problem. Okay, so I'm assuming that you've paused this question and thought through it. Again, the answer here is C, which is the RR conflict. I'll show you the steps because this could feel little lengthy. So what I've written here is I've written down the solution, right? So what we have done here is we have created all the LR1 items from I0 to I13. Okay, from I0. Again, you just have to follow the steps carefully. If you just follow the steps to create LR1 items, you will get I0 to I13. These are all the LR1 items that you will get. Now, if you notice carefully, look at I6 and I9. Look at I6 and I9. If you look at it, this production part is the same. Look at this. This production part and this production part are exactly the same as this. It is only the look ahead symbols that are changing. Here look ahead symbol is C. Here look ahead symbol is D. Here it is D. It is C here. So if you try to merge these two states, let's assume you try to merge state I6 and I9, right? And let's assume you create a new state called I69, right? That I69 will look like this. B generates E dot C or D, because you have C or D here. Similarly, you have C or D here, or D or C, whichever way you want to write it. Now, again, I told you that this is time taking because you have to get to this concept. Again, in the early stages of your preparation, especially in early June, it's okay to go slow, perfectly okay. With time, you'll improve the speed of it. So now when you draw the parse table, look at it. Again, we've also drawn the parse table carefully. If you notice the parse table for I69, right, on symbols C and D, you will encounter an RR conflict. Here it says R5, R5, R6, R6. Now what is R5, R6? What is the 5th production rule and 6th production rule, you might ask. Okay, so let's assume this is the 1st production rule, this is the 2nd production rule, this is the 3rd, this is the 4th, this is the 5th production rule, this is the 6th production rule. So if you notice the parse table, you're getting a conflict, RR conflict between R5 and R6. Okay, so look at this. You're getting an RR conflict between production rules 5 and 6. Okay, so this question is all about detecting that RR conflict. Okay, again, I understand that this could be time taking, so it's okay to take more time, but this sort of problems will help you clarify on how to construct the LR1 items, how to construct the parse table, how to detect conflicts very easily. Again, we have pre-drawn this solution, or we have pre-drawn this whole thing so that it will be easier and faster for you to explain. In case you want to do this carefully, pause the video here. First draw I0, then I1, I2, draw the whole graph, draw the whole parse table carefully. Again, the trick here is I6 and I9 merging to create state I69. Okay, that's what creates RR conflict. Again, we've shown a lot of examples in our course videos and solve problems where we explain how to detect similar type of conflicts, whether it is SR conflict or RR conflict, right? So please go through that. Again, the process is straightforward. The process is very simple. You just create your LR1 items, try to merge states, construct your parse table, look if you're getting some conflicts. That's all. Okay, so let's go to the next question. This is a very interesting question. Again, here SDT means syntax directed translation. That's the topic that we are in. Okay, so you can think of this as your production rule and then the semantic action corresponding to it. Okay, so this is the production rule in your grammar. This is the semantic action corresponding to it. So read the question carefully, pause the video, try to solve it. This is a very simple question. If you know what is the meaning of semantic actions, if you know the basic concept of syntax directed translation, this is actually a very easy question. It is lengthy to read, but it is easy to solve. Okay, I'm assuming that you have spent some time trying to solve this problem. The answer is 94. Let me explain the answer. Okay, it's actually very simple. All you have to first do is you have to derive this string xciv. You have to derive this string xciv from the starting symbol. First try to derive that. Now we have also drawn the whole tree here, the derivation tree. Look at this. Okay, just for speed. So you have s generates xtu, x can generate, again, what do we want? We want xciv. So we got our x here, then t can generate c, right? U can generate iy. So and y can generate v. Again, you can look at the production rules. Intentionally, we gave lot of production rules to confuse you. This is only to confuse you. But if you think carefully, you can come up with this derivation. Let's forget about the semantic actions for a while, right? So S generates this. So we got X, we got C, we got I, and we got V. First, what did we do till now? We just constructed the parse tree. All we have done now is to construct the parse tree. We have not done any semantic actions. Now, if you notice, look at this, S generates XTU. Look at this, what is the semantic action corresponding to it? S generates XTU. Now, what is the last production rule that created this? What is the value of X? Remember, see, look at this, when you have X, whenever you have terminal symbols, right, you just use that value there. Look at this, you have a terminal symbol here 10. You have a terminal symbol, not 10, You have a terminal symbol X here. What is the value of X? If you read the question carefully, it clearly says, look at this, where is our X here? Okay, where is our X here? Okay, where is our X here? Okay, look at this, our X is, X dot val is 10, V dot val is 5, I dot val is 1, epsilon dot val is 0, C dot val is 100, I dot val is 50. So we are given all these values. All you have to do now is plug in those values. X, you get 10, right? Very simple. C is 100, I is 1, V is 5. Now, when you applied this production rule, which is U generates IY, what did it say? What is the semantic action corresponding to it? Look at this. U generates IY. What is the semantic action? U dot val is Y dot val minus I dot val. So write that rule here. Look at this. This is the production rule that you used, right? U generates IY. And the semantic action corresponding to it is this. So now what is U dot val? U dot val is Y dot val, which is 5, minus I dot val, which is 1. So U dot val now is 4. Very simple. Now, Now let's see what you have. So this is done. So you got the value of 4. This value is 10, right? T generates C, right? Again, you can see this, T generating C. Look at that. What does it say? T generates C. So T dot val is same as C dot val. Okay, that's the semantic action, right? So what do you have now? What is T's value now? T's value is same as C's value. So T is 100, U is 4, X dot value is nothing but 10, right? Again, here you're getting T as 100 because T dot val is C dot val. Because of this reason you're getting it. You got 4 here because of this reason. Now in the production rule which says S generates X T U. What is the production? What is the semantic action? If you go up and see, the semantic action clearly says S dot val is T dot val minus X dot val plus U dot val. So we have just written that here. So if you notice here, okay, so if you notice here, that's exactly what we have written. What is T dot val? T dot val is 100. What is U dot val? U dot val is 4. What is X dot val? 10. 10 minus 100 plus 4 is 94. And S dot val is what is returned back, right? S dot val is 94. That's what is returned at the end of the whole syntax directed translation, right? So very simple. Again, in any syntax directed translation with the semantic actions, first simply parse it and just apply these rules. Just apply these rules, in this case in a bottom-up fashion. Very simple solution. Very easy to crack. Easy to score marks also. Okay, so let's go to the next question now. Oh, this is a very good question. Again, it's a simple question nonetheless. It's a simple question. Often such questions are asked for 1 mark. If you know the basic concept of what is a basic block, given this code fragment, if you know the basic rules of building blocks, then it's simple. Again, this all boils down to the concept of leader and things like that we have discussed in the course videos. So please pause it and try to solve it. I'll explain the solution in a couple of minutes. Okay, I'm assuming you have thought through it. Again, remember, what are the rules of creating leaders? This is the first statement in my code fragment. So this is my leader 1. Okay, this is a simple statement. This is a condition, right? Till here, everything is okay. Now, after this, whatever is here. Now, after this is the executing statement, right? Remember that this is the target of a branch. Remember how are leaders defined? Leader is either the first statement. There are a bunch of rules for determining leaders, right? This I'm saying is a leader. Why is it a leader? Because this is a target of a branch statement. Conditional or unconditional, doesn't matter. It's a target of a branch statement. Why am I saying it's a target of a branch statement? Because if this condition is true, the control flow will go here, right? Again, we are still in the same thing. Again, this is the next leader. Why is this the next leader? Because this is also the target of a branch statement. Because if this condition is false, the control flow will come here. This is a simple statement. And again, this is also a leader. Why is this a leader? Because this is the statement that follows. So this is the statement that follows the branch statements, that follows the branch statements, right? So that's why this is also a leader. Now, if you have the leaders, you can break it into basic blocks very easily. So this whole thing is one basic block. This whole thing is one basic block. This whole thing is one basic block. This is another basic block. So you have block 1, 2, 3 and 4. So the answer here, the number of basic blocks in the code segment is 4. That's all. Again, this is a very simple code. If you know the concept of leader and how to determine, again, this is a leader because it is a first statement, right? So if you know these simple rules that we have discussed in the course videos, it is very simple and straightforward to solve these problems. We hope you have enjoyed this compiler design session, and unfortunately we had to terminate the live session because of a technical glitch with my internet connection, because I'm traveling. I had to travel in an emergency. So I hope again the next set of subjects, as I've just mentioned, will be engineering maths and discrete math. So please prepare for that. We will list down the topics for every live session a few days in advance. So if you're starting a new subject, consider doing engineering and discrete maths. So all the course registered students who have not yet covered engineering and discrete math, it is perfectly okay. We'll add all these videos in the course flow itself. You can watch these videos and solve these problems in the course flow itself when you reach those topics. So don't worry about missing out on this.